Advanced Algebra Chapter 7, Lesson 7, continuing to look at inverse relations, and I want to take a look at a type of homework problem that ties together everything that we've been looking at in the past few lessons and do a few examples of them so you know what to expect on your homework and on the quiz or a test. The instructions you'll find in your book go like this. For each function f, so they're going to give us a function, they want us to determine what the inverse of that function is. And then they want us to determine the domain and range of both the original function and the inverse function, and then to determine whether that inverse relation is actually a function or not. So this is kind of a four-step process, and the way we want to do this is we want to begin the problem before we do anything is to determine the domain of the original function that they give us. And once I've done that, at the same time I'm calculating, or I am determining what the range of the inverse will be, because remember the x will become y. So I'm actually killing two birds with one stone here. Then the second thing we'll want to do is determine the range of the original function. And again, I want to do that because the range, those y values, are going to become the domain of the inverse. So again, I'm killing two birds with one stone here. So before I begin, I want to answer these two questions, which in actuality are answering four questions. Once I've done that, then I want to go ahead and determine what the inverse is, and again we're going to do that algebraically by making the x values or the x variable a y and the y variable an x, and then solving for y. So that answers the question of determining the inverse. Then finally I want to look at that algebraic expression and determine whether that inverse relation is a function. And you remember it will be a function as long as there's not a plus or minus as part of the solving for y. And the reason that it's going to be a function is because if I'm only getting one output, when I put in an x value, its input, then that makes a function. So I'm going to give you the quick walkthrough of the one that they have in your book, the example they have in your book, so you can kind of follow that along if you need, and then I'll do a couple of examples at the end. So here they give us the function x plus 1, the square root of x plus 1. So the first thing we want to do is to determine I'll get it. The first thing we want to do is to determine the domain of this function. Now you remember, because it has a radicand, we're going to have a restriction to our function. I need the radicand to be greater than or equal to 0 because it must be positive. So solving this inequality for x, I have x must be greater than or equal to negative 1. So the domain of f of x is going to be all real numbers such that the x values are greater than or equal to negative 1. So I've answered the first question, and then later on when I determine the inverse, this will become the range of my inverse. So I've actually answered two questions here. Okay, so in your book it describes that here the radicand cannot be negative, so x must be greater than or equal to negative 1. Now I need to determine the range. Now you can graph this function to determine the range if you'd like, or you can think about this. This radicand is going to be negative. Is not going to be negative, is going to be positive. And when I take the square root of that positive number, it also is going to be positive. So I know then that my range is going to be all positive numbers. So I can then calculate my range then. The range of f of x then is going to be all real numbers such that those y values are greater than or equal to 0. They are positive. Now that I've done that, I can go ahead and calculate what the inverse is. And again, I'm going to do that by making this y value, and remember f of x simply means y. I'm going to change that y value for an x and that x value for a y. And so I have that here, and now I'm going to solve for y. Now to unsquare this, I need to square both sides. So I'm going to square both sides, and then I'm going to subtract 1. So the inverse function then is x squared minus 1. Now I want you to notice that they put this inverse here, and this is very important that you do this at this point. because we found the inverse. Now remember, the reason we want to do that is because of this. If I just had y equals x squared minus 1, that does not indicate that this function came from anything else. And remember, this function came from the original function, so it's going to inherit certain characteristics, particularly in relation to its domain and its range. If I simply looked at the function y equals x squared, in other words, if I just simply looked at this expression here and I said, what's the domain? I would say, well, it's all real numbers because there's no division by 0 and there's no square root. However, when I say this, that is the inverse of something else, then I have to go, okay, this domain cannot be determined by inspection. I have to go back to the function from whence it came, and that domain of that original function is going to become the range of this function, and the range of this original function is going to become the domain of this function. Okay, so it's very important. The only way I would know that is if I had an indication that this function came from some other function, and this inverse notation is what indicates that. So it's very important that we use inverse notation. Now, this is the inverse function, and now I want to know what is the domain of this function. Well, the domain is the range of this function, but the range becomes the domain, so the y values become x. So this range, where all y values are greater than 0, now become the domain of this function. So the domain of the inverse of x is all real numbers, such that, and I got to change this y into an x is greater than or equal to 0. The range becomes the domain. And then the range of the inverse, again, comes from the domain of the original. So I take the original domain, this right up here, so this is going to be all real numbers such that, and I'm going to swap this x and make it a y, the y values are going to be greater than or equal to -1. So you can see by taking care of the domain and the range before I begin, I've actually answered these two questions as well. I simply swap the x and the y because, as we've been talking all the way through, that's the principle of the inverse. X values become y, y values become x. Okay? The final part of this question then is, that just says that, is the inverse a function? And to explain. Now, the inverse, let me go back to what that is. The inverse is x squared minus 1. Is this a function? Well, there is no plus or minus related to this. I didn't have to take the square root of anything to solve it. Therefore, when I put in one x value, I'm going to get one y value out. So the inverse is a function. And the explanation is because for each x value that goes into the inverse function, there will be only one y value produced. Okay, so make sure as part of your answer you explain, and the explanation is for each x value in, there's only one y value out, so therefore this is a function. So it's kind of a little bit of a long process, a little bit of a long problem. There are 5 questions to answer. Make sure you answer all of those in order to get the question correct. I'm going to do 2 or 3 examples on the next in the next few moments, so if you'd like to watch those to have more of an example, then go ahead and do that. Let's take a look at number 23 here. So the original function is 3x plus 4, so let's determine the domain and the range of the original function. So, whoops, I'm going to need something other than black so that you can see that. So the domain of f of x, which is the original function, there is no division. Let me back this up. Let me go colon here, okay? There is no division and there is no square root, so the domain is going to be all real numbers. The range of f of x, again, because I'm putting in all real numbers, I'm going to get out all real numbers. I could graph that if I needed to, or I can take what I know about linear equations. Linear equations or lines go on forever in both directions. Okay. Now right here, I could go ahead and determine the inverse domain and range right now because I'm simply going to swap these. So the domain of the inverse of x is going to be this range Okay? And the range of the inverse is going to be this domain. So it simply swaps out. Now, no big deal to here because it's real numbers for both. Make sure you indicate what domain you're using, f of x and inverse of f. Use the proper notation so it's easy for me to see which one is which. Okay? I then want to determine the inverse function. So I'm going to take this f of x equals 3x plus 4, and I'm going to swap out the x for the y and the y for the x. So f of x represents y, that's going to become x, equals 3, and that x is going to become a y. And now I'm going to solve for y. So I'm going to subtract 4 from both sides. Go ahead and do this. Minus 4. And then I'm going to divide each term by 3. And I would suggest you do it like this because it makes the linear equation easier to see. Now remember to swap the inverse notation for this y. So the inverse function is 1/3 x minus 4/3, which is also a linear equation. Now, is this inverse a function? Because there is no plus or minus, I did not have to take the square root of anything, then the inverse is a function. So f inverse of x is a function. Explanation, because each x value produces exactly one y value. Okay, and that's your explanation. Okay, all right, let me do another one here. I want to do number 55 here because it has a couple of interesting things going on. The first thing we want to do is to determine the domain of this function. So the domain of the f of x function is going to be all real numbers. Now, I know it has a denominator which cannot be 0, so I need to set this equal to 0 or not equal to 0 and determine what that's going to be. To unsquare this, I take the square root of both sides. That gives me x plus 1 cannot be 0. Square root of 0 is 0. So x cannot be negative 1. So my domain is all real numbers as long as or such that x is not negative 1. Now I need to determine the range. Now the range of this function is a little bit more difficult. You may have to graph this and pick up the range from there. I'm going to kind of discuss what I know about this. First of all, I know that the denominator will never be 0, which means this fraction will never be 0. There's no way for me to make this fraction equal to 0, and therefore the y value will never be 0. I also notice that even if this number inside is negative, I'm going to square it, so it's going to be positive. So I know that y is not going to be 0, and I also know that y is going to be positive, or greater than 0. So together I know that y is going to be greater than 0, okay, because it won't ever be 0, and it'll be greater than 0. So my range then is going to be all real numbers such that y is greater than 0. Now again, because I've already done this, I can go ahead and determine the domain and range of my inverse right now. I'm simply going to switch the domain for the range and the range for the domain. So the domain then of my inverse function is going to be all real numbers such that, and I take the range here, so this y, but it's going to be changed out for an x is greater than 0. So this becomes my domain. Making sure I change the y to an x, because now it's my domain, those are x values. The range then of my inverse is going to be all real numbers such that, and I'm going to take this domain and I'm going to change that x to a y is not negative 1. So my domain becomes my range. So I've answered 4 parts of my question. Now that I have my domain and range determined, I can determine what the inverse function is. Now this f of x, which is y, is going to become x. Whoops, that's a little sloppy. X. And then 1 over, and then this x is going to become y, so that's y plus 1 squared. And now I need to solve this expression for y. In order to remove this fraction, I'm going to multiply both sides by y plus 1 squared. So this is going to be x times y plus 1 squared is equal to 1. I almost said 1 over something, but that reduces out because I multiply both sides by that. I then need to get this squared thing by itself so I can undo that or unsquare it, but I have to divide by the x first. So y plus 1 squared is equal to 1 over x. Now I need to take the square root of both sides. So that gives me y plus 1 is equal to, the square root of 1 is 1, and then I have the square root of x in my denominator. And then this is plus or minus. Don't forget that because I took the square root. And then I'm going to add 1 to both sides. So y is equal to 1 over plus or minus the square root of x minus 1. So now swapping out this y for inverse notation, I can write my inverse function is 1 over plus or minus the square root of x minus 1. So that is my inverse relation. And now I will need to answer the question, is this a function? And the answer to this is no. And because when I put in one x value, each x value will produce 2 y values. Okay? Because when I put in a positive x value here, I'm going to take the positive root and then solve this, and then I'm going to take the negative root and solve this. So each x value is going to produce more than 1 y value or 2 y values. Therefore, this is not a function. Okay? So a little bit complicated. Again, with the range, more difficult to tell. So just go ahead and use your calculator to graph it and then get a picture of the range using that method. Alright, I'm going to do one more down here if you would like to watch it, this number 58. For number 58, a couple things going on. We have a square root and we have it in the denominator, so that's a couple of interesting things. So again, the first thing I'm going to do is figure out the domain of my f of x function. So it's going to be all real numbers, and I have a denominator and a root. So two things going on. So because this is a radicand, I know that my radicand, negative 2x, must be greater than or equal to 0, meaning it must be positive. Now I can stop right here and eliminate equal to 0, and that's going to take care of my denominator, because my denominator cannot be 0. So even though the radicand could be equal to 0, because it's in the denominator, it can't be. So this is going to be negative 2x must be greater than 0. And then I'll go ahead and solve this. I'm going to divide by negative 2, so I have to switch the sign, so x must be less than 0. Okay? It must be a negative number that goes in here, which makes sense. If you put a negative number in for x, you're going to have a negative times a negative, making it positive, which takes care of the negative radicand. So my domain is going to be all real numbers such that x is less than 0. I have to put in x values less than 0. So that is my domain. Now that I have the domain of my function, let's figure out what's the range of my f of x function. Now, again, it's going to be all real numbers, but because my domain is restricted, my range is also going to be restricted. Okay? Now, again, my domain, you can graph this if you'd like. I'm just going to take what I know about functions and figure out the domain that way, or the range, excuse me. Again, the denominator will never be 0, so the y values will never be 0. And again, because I have a positive radicand always, I'm going to be taking a positive number always. This fraction can never be negative, so again, y must be greater than 0. So again, I have an expression where my range is going to be all y values are going to be greater than 0. There are not going to be any negative y values. Okay, that was kind of a weird brace. Let me do that. Okay, and again, if you need to graph that, then you just go ahead and graph that and determine the range from there. Again, because I have the domain and range figured out already, I can do the domain and range of my inverse. Okay, the domain of my inverse is going to be the range of the original, so all y values such that, and instead of y, that's going to become x. X is going to be greater than 0. And then the range of my inverse, again, I get from the domain of my original. So the domain here is all real numbers such that, and here x is greater than 0, but I'm swapping that out for my range, so y is going to be less than 0. I think I said greater than, that's going to be less than. So I have the domain of my original and the range of my original and the domain of the inverse and the range of my inverse, so now I can go ahead and determine what the inverse actually is. This f of x, which is a y, is going to become x, and then this is 1 over the square root of -2, and then this x becomes a y. To remove the fraction, I'm going to multiply both sides by the denominator, so this is going to give me x times the square root of -2y is equal to 1. I then need to divide by x, so the square root of -2y is equal to 1 over x. I then need to square both sides to remove the square root sign, so this is -2y is equal to 1 over x squared, squaring numerator and denominator. And then I'm going to divide by -2, excuse me. And remember, dividing by -2 simply means multiply by the reciprocal. So that's going to give me y equals 1 over -1 over 2x squared. Okay, this negative sign times the positive. So my inverse function then is -1 over 2x squared. So I have my inverse function, and now I need to answer the question, is this inverse function, I already call it a function, it's actually relations right now, is this inverse relation actually a function? And because there's no plus or minus, the answer is yes. And the explanation is because for each x value, only one, or exactly one, y value is produced. Okay? So it's a function because for each x value substituted in the expression, we'll produce only one, exactly one, y value. So again, that kind of ties together everything that we've done up until this now in regards to inverses. I know it's a lot, but just walk your way through it, do one step at a time, and then when you get to the end, you'll have everything in a nice, neat little package. There's one more thing we want to talk about in this lesson. We'll do it in a short video. So we'll wrap this up here.